All right. So, a very good evening, everyone. Welcome to the third webinar of NACDeC-VIII, the design of a supersonic combat vehicle. And firstly, congratulations are in order to all of the teams who are here. Congratulations on successfully clearing stage one, the design competency examination. So, kudos to you guys. So before we take this webinar a bit forward, I would want a couple of you to unmute and have an interaction as to how did you feel the exam was, because we are definitely going to give you a feedback post this, but I would love to hear from you how you felt the exam was. Where did you personally face a difficulty? So that is something that will help us the next time if we are going to do it. All right. So the floor is open. One of you could probably start off the discussion by saying how was the design competency examination for you, what challenges did your team face, and how did you possibly mitigate it? Go ahead, you could raise your hands, and I would give you an opportunity to speak. So guys, please be proactive with this. Really want you to interact. I see no hands raised. Does that mean it was that bad or that good? Yes, team Macworks. Please go ahead. You can switch on your video cam as well. And
Good evening, Pranav.
yeah, hi,
So,
good evening.
uh, my favorite part of the quiz was attempting the first question. That question took 70% of our time, frankly speaking. And that was the most eye opening question for all of us. It showed where our cracks were, it showed what we excelled at. We had a team member who pointed out very correctly that the coordinates were not actually in sync with what we expected, and that was really the eye-opening moment for us. It helped us fix us what we have to go going forward.
Right. So just to add a bit of insight to that, that question is the brainchild of Professor Panu. The first question that you're talking about. So that is something that was really, I agree to that. It was really interesting. And any other feedback that you would like to give Team Marcos? I guess not. So please go ahead, Team Aero Indians. You can unmute yourself and you can turn on your video if that's convenient for you.
Good evening, sir.
Good evening.
Sir, actually, according to me and my teammates, so I think Pansar wants to say something. After that, I'll continue.
No, it's okay. I mean, I wanted to just respond to that feedback regarding the question. Okay, so the question that some people have liked, the number one question, it is basically a true story. If you can have a look online, it's called as a rolling bomb. And that was the bomb that was launched to knock off the Mohane Dam and the other dam, which crippled the production of firearms by the Germans. So basically the assignment, question number one was based on the design of the Lanchester aircraft. And all the data that you saw is actually true data, except we messed up with the coordinates slightly, which many of you pointed out, and I think you must have corrected. Okay, so it was just to give you a feel of what is meant by initial sizing. That's an initial sizing problem. When the customer gives a mission profile and the requirements, how do you arrive at the first estimate of the gross weight, which is what you also will be doing now. Okay, so thanks for the compliment. I just wanted to add this small point. Okay, let's continue.
Great. Team Aero Indians. you were going ahead with your feedback. Please go ahead.
So, like the questions, the level of questions were quite good and they were thought provoking. The only problem was in management of time. Like I felt and my teammates also felt that the question paper was quite lengthy. So how we dealt with that was like 2 questions and 3 questions we divided. We made the teams of 2 and 3, and we worked on that accordingly. So if the length of the questions would have been less, then we would have discussed properly each and every question, which I think is not possible. So overall, it was a good experience.
Okay, can I comment to this, Pranav?
Yeah, please go ahead, sir. Please feel free.
I want to make 2 comments. Number one, if you found the question paper was lengthy, you are right. It was intentionally lengthy because we wanted to see exactly what you did, whether the team has the ability of dividing the workload amongst each other and addressing the problem. That is number one. Number two, I would urge you, all teams, to, now there is no time pressure. Please solve the question paper fully. If you really want us to give you feedback, I will give you now almost a week's time or whatever, 10 days time. Solve the question paper again under no pressure. Use the internet, use ChatGPT, try to solve it and give us the solutions. You will learn a lot in solving this question paper. And also, we did not expect, in fact, Pranav, you should remember, I had told you that I don't think any team will be able to solve all the 5 questions. In fact, we were thinking that some students will strategically leave out some questions. That's fine. The aim was not to ensure that you do all the questions. The aim was to check your preparedness and to give you a feel about the kind of workload that is there in front of you. Okay, so let's go ahead. Anybody else would like to comment something?
Sahar, I think you would like to say something?
Hi Pranav, hi sir. Good evening to all. Regarding the question paper, we felt that it was well balanced. All the aspects of UAV was considered aerodynamic stability, design. So we teammates like divided the work who was expert in each of their respective field. So overall well balanced paper of all the UAV aspects. Yeah.
Yeah, there was no structures part in that, unfortunately, and that is difficult.
Structures part was only missing.
It
Apart
is
from
difficult.
structures, everything was there. Yes.
It is difficult to incorporate structures. Yeah.
Yes,
Okay,
sir.
never mind. Let's go ahead now.
All right. Is there any other team? If not, then I would like to start by giving my feedback on this and starting. Okay, Team Abhimanyu 8.0, go ahead.
Hello, sir. Like the exam was really good. The questions were like really like well structured, and like my teammates like really like managed to divide the work quickly and take the like questions that they could handle. I wish we could have done much better, and I wish like we would have like had more time. But yeah, the paper was like good.
No, don't worry. Since you are shortlisted, it means you have done well. Don't worry. Those who did not do well have been eliminated. And only those who did well in the question paper are shortlisted. So don't worry at all. You have done well. That's why you are here.
Thank you, sir.
All right. So now, thank you all the teams for giving your insights. Now, I think it's time that we share our insights as to how we thought this process would go, where it met our expectations, where probably could have been better, and some learnings for the future. So this is where I would like to come in. So when this paper was being designed, so one request, just put down your hands, all the teams. Otherwise, I'll do it for you. Yeah, perfect. So when we were designing this question paper, we had a good long discussion as to what to give you that would really challenge you, number one, and give you a real feel of how design problems actually work in the real world. Okay. One thing I think you must have realized, the objective was not to cover all the questions. I don't think that was really possible if you really gave a very good look at question 1 and 2. Question 1, like someone said, took 70% of the time. It would have taken more if you had dedicated your sole effort to that. That was a very it was a tough nut to crack, I would say. It really it really forced you to think in all terms of design. And question number 2, I don't know if you noticed that data that I had given was for Airbus A380. Okay, so Airbus A380 data that was provided to you, obviously with some estimates here and there, and you were asked to kind of plot a constraint diagram. Okay, so that was also something really challenging at different thrust settings and different weight settings, and you need to look at different boundaries, stall conditions, dynamic pressure heads, etc., VN load. A lot of things were required to be done in that. That was again something which was decently challenging. Then I think there was one very straightforward question on airfoil has been tilted to a certain angle, and how you just have to break it into components, simple vectors, and get the effective angle of attack. Okay, that was something that we felt was extremely straightforward. Another question was really straightforward. Tell us the challenges that you are facing in the design of a supersonic UAV. That is something that you should have as a team discussed, and something that I am sure you must be comfortable with. Now, the last question on stability. Now, stability for people who have studied aircraft stability or are studying aircraft stability in their courses, you would understand that stability is not something which is very easy to understand. I have graduated, but still, it is difficult for me to make sense of it sometimes. But I would say it was meant for you to apply yourselves more, okay? Because a lot of things were logical in that thing. Okay, you were given a simple graph, static margin was given, and you need to calculate the neutral point, etc., and you need to size the tail. Okay, that was something that needed to be done. Okay, now I would like to go into the depth of all of this, and the team has made a great presentation for that. I would like to share my screen and officially start today's discussion. Could you just give me a thumbs up when you can see my slides? I'm just going to make the slide show mode. Just a second. And I'm just going to hide this floating meeting control. All right. Could someone give me a thumbs up if they can see this? Perfect. So thank you so much. All right. So yes, so this basically, since you guys have already cleared the design competency examination stage, now the next thing or the next big task ahead of you is the midterm report. Another beast that you need to tame. The deadline for that is 15th of March, as you are well aware. And so we'll slowly look at what has to be done and what have you done right so far, and where we can, come in and help you guys out. Moving on. Right. So let's have a look at, stage one, what it actually was. So question one, formulation of SFC. Now, a lot of you, you did not really take into consideration a lot of variables that were given. When you look at question number one, the Lancaster problem, it was a pretty meaty problem. A lot of data was given to you and you need to design it. Okay. So we saw many places there were a lot of calculation mistakes. There were basic mistakes as well. All right. We are not naming the teams, but definitely we would recommend that you go back and revisit your basics for some cases. Many places where you need to calculate the distances of the outboard sections and all, outboard journey. Some assumptions were wrong. There were some very silly calculation mistakes. I think that is something that you need to pay close attention to. One thing that I would like to point out is, please guys understand the need for proofreading anything that you submit. Okay, this happens to the best of us. Whenever we write something, we have something in our head, and when we pen our thoughts, maybe we might miss out on something. Right? So it is a very good idea to keep the last 10-15 minutes for proofreading and editing. Okay, so you can just go over your document and just see where you probably missed it, because you also understand it's an iterative process. If you messed up one value, the entire thing goes for a toss. Okay, that is where I would say that you can probably pay more attention. Question two, I was not fairly satisfied with a lot of teams' answer. Okay, because there were a lot of data and I did not think you made a good use of the data. I have hardly come across teams who have done justice to this question. Okay, so there were various things that I expected. We've expected you to tell us the critical boundary, the dynamic pressure boundaries, stall limits, the load factor limits, etc., etc. Those were the things we were expecting from you, but we did not kind of get that. A lot of you, in a hurry, I think, or just to cover questions, you basically just try to attempt it willy-nilly. And that thing did not make a lot of sense while evaluating. So I had mentioned that earlier in the webinar as well, that whatever you do with 100% conviction. Okay, it's okay if you leave something, but whatever you're writing, make sure that it is absolutely something that is not very obvious. So question 2, I have my reservations on how you did justice to it. Question 3 was a fairly straightforward question. The lift and drag had to be resolved into vertical forces, and there was a difference between effective angle of attack and angle of attack. So there is that is something that a lot of people missed on. Okay, that is something that a lot of you missed on. There were definitely calculation mistakes here, but all in all, I was satisfied with the way this question was attempted. Okay, moving on. Question 4. Now, this is something where my contention again starts. Okay, if you look at this diagram, isn't it obvious that area 1 is the only feasible region? Because if you look at area 2, 3, and 4, they don't meet the climb gradient. Okay, so anything that is below the climb gradient is infeasible as it is, right? And other things that were given to you was simply just to confuse you. We had given you a scary looking diagram, landing distances, stall limits, etc., etc. But the gist of the entire thing is only area 1 is a feasible area. 2, 3, and 4 is something that is infeasible and has to be disregarded. The reason you have to mention, but many people have taken a different stance or a different approach to answering this question. So these are some basic things I would really urge your team to revisit such basics. And also coming now to question number 5, this is one of my personal favorite questions, the stability questions. Whenever you're calculating neutral point, you need to take into account the contribution of the fuselage as well, right? You might say that, oh, fuselage does not, give a lot of moments, does not produce a lot of moments. It does. There is a CM fuselage, right, that needs to be considered while designing. Many people miss that part. Hence, the neutral point calculations were not exactly correct. But all in all, you got the concept. But, the formulas are pretty easy to get. You had access to everything, ChatGPT, everything. There were many places where calculation mistakes were there. And, there were very silly questions being asked at the time of the examination. You have been given 2 parallel lines. I don't think you needed intercepts to do that. So simple mathematical equation to help you do it. Also, this made me realize that you guys are still not clear on what is stability and control, the difference between the two terms. Okay, there is something called as inherent stability of an aircraft. And then there is a concept of control. Okay, there's a difference. They're not the same. They intend to have the same goal, but the way they achieve it is different. Okay? So that is something that you need to pay some attention to. Again, while designing the tail, we got a huge variety of numbers, starting from all the way from about a 0.1 meter square tail area to about a 10 or a 11 meter square tail area. So one more thing, as design engineers, you need to, you should be very cautious of what numbers are you pitching. When you see numbers like 15, 20 being as tail areas, look at the scale of the problem. And then, there should be an alert that, okay, this does not really make sense to me. And this is probably, I need to reevaluate it. Okay, and this is where your peer-based learning comes into picture. You can always have it cross-checked with another person in your team. Does that make sense to you? So that is all in all the feedback we have. Some couple of pointers that I have, some suggestions for you guys for the challenges for designing the supersonic UAV, right? We have detected the use of AI tools. It has been very clear. We are issuing a very strict warning to you guys right now because I don't want to name the team, but I have made note of the teams who have used those tools because we have a very good plagiarism checking software here at IIT Bombay. Okay, we have invested a lot in that software and it can catch almost anything. So we know where you have taken it from. Okay. So this is a very strict warning that we are giving as a organizing committee to you. If we detect such thing in your midterm report as well, we are straight going to disqualify you, no questions asked. Okay. Take this as a very strong warning from our end that this kind of thing is not expected. Otherwise, there's no point of it, right? This was a question where you had to explain the challenges of this particular problem statement, this particular mission. you have mentioned supersonic UAVs in general. Okay, I get that. But, I was looking at something more personalized to this problem statement. Okay, this is the mission that you are designing it for. What would be the exact challenges that you are looking at? So that is something I personally wanted to see. And that is something that did not come out as beautifully as I wanted it. But then again, you have time. You can definitely look back, understand what needs to be done, and, make those corrections and where required. Okay. So that is where it comes to the feedback part. One more point is please give references and citations wherever you're using some formulas. There are a lot of approximation formulas out there. Okay. Just because aerospace, it is really complicated to handle a lot of complex parameters. So people simplify it by using approximations, etc. It's okay if you're using them. If it makes sense, go ahead, use it. But please do provide proper references and citations, formulations, etc. Where have you taken it from? Because we were lost. Where did you get this from? Is this something that makes sense or not? We were finding it. And that took us a lot of time. Okay. Another thing, I had mentioned this earlier also. For some of you, it was a humble request to please keep your handwriting legible. For some people, this was a huge challenge that we faced. We were trying to make a sense of what you had written. Okay, you may have thought it well, but you may have articulated in your head well, but when it came to penning your thoughts, I think some teams did not do a very good job at that. So it is very helpful, when you're showing initial sizing calculations, you could have a good flow chart where you can show your design process. You can write in steps that really helps the evaluator to see your thought process, right? Again, this is a point that I've already mentioned. Look into the practicality of the number. You could just do a simple literature review search. Does that number make sense or not? This is something that I would expect you guys to, do by now. Okay. Because many times we found the numbers that you were quoting were really infeasible. Okay. And please don't do this going forward with the midterm report and the final report. Okay. Because going here on forward, the evaluation is only going to get tougher and tougher. And we will be calling you for a Viva. And if you're not able to justify it in the Viva, then you will be in some kind of a trouble. Yeah, right? But then again, overall, the design competency examination, the objective was, we have opened NACDeC to other branches as well. And I think it is safe to say that many of you have done a fairly decent job. Okay. So kudos to you on that. And a job well done for that. Now looking forward, we would really urge you to look at the nitty-gritties of the problem statement. Supersonic UAV vehicle designing is really challenging. So you need to look at the practicalities of how this design process actually works. Okay. Right. So now before we start phase 2, are there any questions that I can address at this moment? Because I would like to start stage 2 discussion, overview of the work to be done. Anyone wants to raise any questions or queries, anything with regards to the evaluation part, that would be good. Okay, Team Aero Indians, you have raised your hand. Please go ahead. I'll just stop sharing my screen for the time being so that I can address better. Yes, go ahead, Aero Indians.
So may I know the type of evaluation, like was it marks based or the approach based? And secondly, how many teams qualified out of how many?
Right. So to answer your question, Team Aero Indians, we have allocated some marks to your approach, but those are based on the amount of effort that we saw for that particular question. Okay. So it is also possible that you may have attempted a question, but we may have simply awarded 0 because those things do not make sense. So your attempts don't matter that much as the depth of your concept and how much clarity you have. Okay, we understand that you are also budding engineers. We did not expect 100% precision, but if we saw major blunders, that is something we have taken into consideration. And as far as the number of teams that have qualified, I don't think we are going to be sharing that as of the moment. Okay, but I think you can take a fair idea. Any other question?
And sir, will the marks of this stage 1 be considered for final evaluation? Or is it just a selection round?
To some extent, yes.
No, I don't think so. No, Pranav, I don't think so. I don't think so. Let us not worry about marks too much.
Yeah.
See, this stage was only to like go, no go. Okay. Because see, I'll tell you earlier, those who might know, in NACDeC, we used to get some kind of a essay or a report or a plan of action, that is now absolutely meaningless with the chat GPT. Okay, as Pranav has already cautioned you, despite that some people have tried using AI tools. Okay, so sorry, the stage one, this particular stage is independent. Whatever you did so far is over. The job is over. There are no marks to be given to you, and these marks are not going to be counted. Now you will proceed to the mid-semester report. Mid-semester report onwards, we start accounting your contributions. Okay. Yeah, go ahead. Ask your question. Better to show your video also when you ask questions. It's better for us.
Okay. Hello, sir.
Yeah.
Sir, my question is,
yes, Team Skybreakers, yes.
You care about the Viva. Is that only for the team leaders or all the members of the team leaders?
It will be for all the members. Whenever it is conducted, it will be for all the members of the team, not just the team leader. We want to see, because we understand that not the team leader will not have expertise across all domains, right? So we want to see as a team, how did you tackle a particular problem, and how did you come up with a solution? Okay, so that is regarding the Viva. We will brief you in detail when we cross that bridge, right? So we still have some time for that, so no need to get worried for that as of now. For now, just focus on doing your work diligently, and just make sure how you are getting to whatever numbers you're quoting or whatever approach you're following. Just be thorough with it. That is my suggestion.
Okay. Okay.
I want to add one small point. This team Viva is not compulsory. This team Viva may not be held if we are convinced that you have done a good job. We will decide about the need for team Viva later. Okay, so don't get worried about it. It may not be there, and if it is there, doesn't matter. It will be there for everybody. So don't worry about it.
Sure, sir. Got it.
Right. Anyone else? Otherwise, I would really like to go to the part 2. Okay. I feel there is no one else. Just checking the chat box once as well. Perfect. If there are any questions in the YouTube, then I would request the volunteers to please, just tell me the questions so that we can address them when they are next. Any which ways.
Also for all the people who are in the meeting, at any point of time, you can just raise your hand and we will take a question. Don't worry.
Team Garuda, you have a question? Go ahead.
So is it necessary to use OpenVSP, or we can use any other CAD software for the midterm report, like Fusion 360 or Onshape?
No, Team Garuda, can you please first put your camera on?
Sorry, sir.
Can you put your camera on?
Yes, sir.
So look, let me also add to the question. Pranav is right in saying that it is not necessary to use OpenVSP, although we recommend that because it's a open source software, specially made for aircraft conceptual design. Whereas tools that you mentioned are general purpose CAD tools. They are not made for aircraft design. But if you decide not to use a tool which is appropriate, if you want to use if you want to use a talwar, where a sword, where you have to use a pin, it is up to you. But we recommend OpenVSP because that is definitely the best tool for CAD related work for aircraft design. Okay? But the choice is yours. But the only thing we ask and we insist is you are going to only use licensed software. If we find out that your software is unlicensed or it is a cheat version, that will immediately lead to disqualification. So if your college has, or if you have officially purchased the software, no problem. Regarding Fusion 360, Autodesk is going to partner with us and they are going to offer free access to Autodesk Fusion 360 to all the team members of all the teams who are in this particular stage. So just wait for some time. We are still working out the details. We are asking them to sponsor the prize money. So that negotiation is going on. Okay. So the answer is you can use anything, but we recommend strongly that but nobody will give you marks because OpenVSP has been used.
So can we use the student version of the software?
You can use any version. It should be legal.
Okay, thank you, sir.
Right. So I think there are no more questions. We'll take them as and when we encounter it. All right. So now, stage 2, what is required, what needs to be done, overview, etc., etc., etc. These are some pointers that we are going to address when we talk about part 2 of this webinar, right? So as you have already seen from the problem statement, these 5 things are what tasks are expected to be completed in the midterm report, right? By now, I'm sure you might have some clarity as to where your design is heading, or at least you might have started, scratching the surface as to which way to head. We are expecting you to, give a mission profile that you are following, methodology that you are going to follow, the aerodynamic parameters, propulsion, and vehicle sizing, right? This is what we expect from you in the midterm report. I will elaborate this a bit further. Now, this is something that we, like to stress on year, something which comes at the heart of any aircraft design exercise, not just a supersonic aircraft design, anything, is something that we call a design methodology, right? Now, this is a systematic framework that, translates your mission requirements and all into a feasible and safe space from where all your constraints are satisfied and you are getting a good design. Okay. Now, this is something that we mention year, but we again and again find that a good design methodology is not being adopted. Hence, we thought it would be a good idea to show you a couple of design methodology flowcharts that are available and how to approach such kind of things, right? Because aircraft design is a very systematic process and you need to follow each step very carefully. And it is an iterative process. Once you complete one cycle of this process, you can come back, tweak the parameters, and come and refine your design. And you can refine it till a stage where you find that your design point is really good and it is, satisfying all your design needs and also is competitive to some extent. Okay. Now, a couple of questions that we get that when do we say that we have a good design point, right? So I'm sure you might have done your constraint analysis. So when you look at a design space, if it is a blank design space, you have infinite design points. Now I put some design constraints, okay? Then you again have some limitations. Your design space becomes limited, but still you have infinite design points. Again, if I include some more constraints, you have another restricted space, but again, infinite design points. Let me give an analogy here, okay? Suppose you are in the market to purchase mobile phones, okay? Now, all of us, I don't know about other people, but I am a person who loves to look at processors, okay? So I would like to see how much RAM it has, what kind of processor it has. So now when I'm in the market to buy a mobile phone, let's say there are about 1 lakh models out there, okay? Now 1 lakh models cover all the way from Nokia 3310 all the way to iPhone 16 and beyond, right? But what is the right choice for me? That is where your mission requirements and constraints come into picture. Now, mission requirements could be something that a user defines. Now, for example, I am a person, like I said, I want minimum 5 or 4 GB of RAM. Let's say I'm giving 4 GB of RAM. That is something I need minimum in my mobile. That limits my design space. So from 1,50,000 models, let's say you are down to, let's say, 1 lakh models, 1 lakh models. Then I say, now, I need at least a 5.5-inch screen display. Okay. Then again, from 1 lakh, I am down to about 80,000. And then I say, no, I want the camera to be at least, 15 or 16 megapixel. Then again, my design space gets, smaller and smaller. If you continue this process again and again and again and again, you will find that the design space gets limited and limited. Okay. Once you have accounted for all the constraints, then what is left is your feasible design space. And when you look at that feasible design space, again, there are infinite points in that design space. So when you plot in terms of aircraft design, when you take your wing loading versus thrust loading graph and you plot all the constraints, so the feasible region that you get, in that you will see there are multiple points. Now it is up to you to evaluate which point is giving you the best performance results. Okay. Now here you don't have to consider external parameters like cost, indirect operating cost, direct operating cost, mission effectiveness, etc., etc. All those parameters, operational efficiency is not something that you need to consider at this stage. Okay. So time and again, methodology is something that we really stress on. So if you look at the flowchart here, it starts off with simply a mission specification. Then, you go into weight sizing, performing constraint analysis, then you could start with the propeller sizing, fan sizing, empennage sizing, wing design, etc., 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 and go ahead to the performance analysis, VN diagram, etc. And whenever you feel that, things are not working out, you could come back and, change some parts, tweak it, and then go again with the flow till the time you feel that the design that you have satisfies all your constraints, mission requirements, and gives you some kind of competitive edge. That is where you need to stop. If you want to ask me how do you know you have hit the ideal thing? You could go for something called as optimizing. There's another thing of optimizing. You can use optimizer tools, but that is not something that we expect out of you. But if you are really keen on doing that, that is when you have hit the gold mine. If you have optimized your design. Okay. Now, this is one thing. Now, again, design methodology can have, it can take shape in multiple frameworks. It can have different frameworks. So one framework that we discussed in the previous slide, it can have another thing. It can have design objectives. You can start with sketching. You can have some selection of aspect ratio, sizing the mission, etc. You can size a wing, etc. So there are different ways in which you can approach. Now, it is very important when you have so many design methodologies, how do you choose which one is right? Okay, because there are a lot of them. So this one has been taken from Daniel Raymer's book, Conceptual Approach. Now, Raymer says that any design methodology, how do you know it is right? If it satisfies your condition, it is right. Okay? It is just methodology is a framework which systemizes your process. Okay? It gives you a direction in which you need to take your design and gives you a common end goal. So that is where design methodology comes into picture. Right? If it is satisfying your needs, it's a good design methodology, in our opinion. And again, one conceptual methodology, when we look at things from our conceptual perspective, we divide it into broadly 4 things. Or we do initial sizing, aerodynamic parameters, propulsion system sizing, and mass breakdown. In this itself, you would cover your structures as well. So you need to see the mission profile. You do a range endurance calculation. You get some initial weight. You go for your drag estimations, constraint analysis, airfoil estimation, etc., etc. Okay, and you need to see where things are going off for you and where things are working for you. And based on that, you need to have synergy between the aerodynamics team, the person who is handling aerodynamics, the person who is handling propulsion, person who is handling structures, person who is handling stability, performance, etc. There needs to be constant communication. So, there was something that I had read upon that if it was up to just the aerodynamic people in the world, all models will be really slender. Okay, it will be really sleek, very beautiful. But the structures guy would have a problem with that. I can't make it so thin. That's not possible. To make it so thin, I need material that would add a lot of weight to it and would add to a lot of problems. The propulsion guy would say, no, if you use so much propulsion, if you use that much weight, use that much composite, it will lead to a problem for me. So, there has to be a compromise. You have to find common ground where all your parameters are satisfied. All subsystems are in sync, be it aerodynamics, propulsion, structures, and stability, performance, all of them are satisfied. It does not mean your aircraft has to be aerodynamically optimized or structurally optimized. You have to have a balanced design. Okay. It can be the best aerodynamic design, but it serves no purpose if it is not structurally stable. Okay, or it is structurally stable but not aerodynamically stable, or does not have good performance parameters. So I think you get my point, which I'm trying to say, right? Moving on. Now, this is one flowchart that I found very interesting because any flowchart, initial sizing, you can make your own design methodology as well. Okay, you can say, hey, I've studied all the design methodologies out there, and this is something that makes a lot of sense for our use case. Sure, go ahead with it. If it solves your purpose, yeah, why not? So, this is one such design methodology where for the particular problem that they had, they made their own design flowchart. Okay, but they started with weight estimations and they went into aerodynamic, etc., etc. But you need to be very clear what approach you are following, and you need to be very clear while portraying it. Okay, when you are presenting numbers, you are showing calculations and everything, graphs, results. Let's be very clear. This is what we have followed. These are the steps we followed. This was step 1, step 2, step 3. Should be very methodical in that aspect. Okay. Now, any questions for this? Just start speaking because I am not able to see your hands. So just, go ahead, start speaking.
Hi, sir.
Don't worry, Pranav. I can see the hands if they raise. So
Okay,
I will, if required, I will interrupt. Don't worry.
All right.
Good evening, sir.
Yeah.
Yeah.
Sir, here the strike zone is mentioned, right? What are the tasks we need to perform at the strike zone? Is it combat, or we have to drop the bomb, or
We are
just
going to
anything
discuss that right
like
now.
that?
I'm taking up questions with regards to the design methodology aspect for now. I'm going to discuss this slide in depth. Okay.
Okay, sir. Thank you.
Any questions with regard to
Any
methodology?
questions regarding the design methodology which Pranav has explained so far? If not, Pranav, go ahead.
All right. Right. So coming to mission profile, this is something that is your heart and soul of the design where you need to focus on. So the mission profile is fairly straightforward. You take off and climb. You cruise at an altitude of 14 kilometers. You ingress. And since it is a combat vehicle, we expect you that this will be carrying some ancillaries on board. It is required to drop that target. It is required to drop those things, those ammunitions, those arms at a particular drop point. Okay, that is where strike has been written. And once it has done that, it has to egress, cruise, loiter, and descent and land. So this is the basic mission profile that we have gone for. Okay, now we want you to design your vehicle just to satisfy this need. Okay, if you design it above and beyond this, it is an added bonus, but it should be in a position to be able to satisfy its basic function, that is striking a target at 1.5 kilometer altitude, and also be in a position to cruise at an altitude of 14 kilometers. Okay, now coming to some other points. When we talk about a supersonic vehicle, what are we talking about, right? So when we talk about supersonic vehicle, we are talking about stealth, right? It should not be easily detectable. Now, it should be really fast. All of this has to happen really quickly. So many people are asking, what are the speed constraints? That is something that we should not give you. Okay, this is you're attacking something. You don't tell your enemy that, hey, I'm going to bomb you at 10 a.m. Just be prepared. So that does not happen, right? So you have to be as swift as possible. At the same time, you have to maintain all of the parameters being balanced. Since you are going to deal with your supersonic vehicles, you will find that fuel consumption is a very big challenge. Your wave drag will be another big beast that you need to handle. Okay, your stability aspect, when you enter critical Mach numbers and how the stability of the vehicle changes, that is something you need to really focus on. And once you get the synergy of all these things, I think you will be good to go. So one aspect is, let's say, I would want my mission, if you are asking as a basic guy who has no understanding, I would want, I would like to be in and out in 5 minutes. But that is just a number. Is it actually possible for me to go in and out in 5 minutes? If yes, then if my design shows it, then great. If it can do it in 5, then our next question is, can it do it in 4? Then you go ahead and do it for 4 minutes. You do it till the point you feel that, okay, this is the best I can achieve. Okay. Otherwise, I am violating certain constraints. You need to leave a good margin, okay, of error has to be there. You can't just be on the border that, we'll only fly at stall velocity. That does not work. Okay. You don't have to design to that extreme just to optimize the vehicle. It needs to satisfy all constraints well. And at the same time, you have to do the mission also. So I don't know, have you come across something called as RCS signatures? That is something that checks stealth. That is something that you will be requiring for a final stage, but that is how we quantify stealth. So that is something we would like you to read up. Now coming to the other two charts and the table that you see. So whenever we are starting with an aircraft design process, you have a lot of literature, right? There are a lot of literature available with regards to, let's say I am designing an unmanned aerial vehicle. I'll have thousands of unmanned aerial vehicles for my category. So I do the segmentation that for my category, I am looking at a weight class of, hypothetically, I'm looking at a weight class of 100 kilogram UAV. Fair enough. Now for that, I would like to start plotting what is the weight and, what would be the aspect ratio, what will be the wing area, etc., etc. From that, I can get a fair idea of where the numbers lie, right? That is what it gives us. Also, now this Raymer has given you a very good empty weight fraction versus takeoff weight, W naught. Now, this is something that you get for your unpowered sailplane, etc., etc. You also have it for jet fighters and jet trainers. Now, this is something that comes with the regression analysis that he has performed. He has plotted the graphs for various models, and he has found similarities, and he has tried to do some curve fitting with that. So that is what this is. I think it could be a great starting tool for you guys, and you could learn a lot from this. It could be a great starter because starting off with weight distribution. I'm not saying this would be a final weight, but this could be a very good starter weight. Okay? And once you have the starter weight, you feel okay at, let's say 100 kgs, I'm able to satisfy everything. Good. Can you do it at 85 kgs? Can you do it at 80, 70, 75? At one point you say, no, I'm not able to do because I'm running into problems. That is why you need to stop. Fine. Going ahead. Now, constraint analysis. Now, this is something, again, which is really important and you need to consider, which I have spoken about it a lot, that if you look at this design space, if you just forget about all the curves, just remove all the curves, entire design space has infinite amount of points. You can choose any one. But when you come up with your constraints that, okay, my stall speed would be this much, my dynamic pressures would be this much, my turn radius would be this much, takeoff velocity or takeoff length would be this much, then you come up with constraints. Once you come up with constraints, you know the feasible region, and the feasible region will also have infinite design points. Now it is up to you to check each and every point, or at least in certain intervals, for you to check and evaluate the performance at every subsequent interval. And then you will be able to say that, okay, I have changed my, wing loading a bit, and because of that, my performance is significantly increasing. It is okay if you increase the wing area a bit, if it is leading to more performance benefits, right? You always have to see things for the greater good. Okay, you don't have to see that, oh, my wing area is increasing, hence my weight is increasing. This is a problem. Let's not do this. It does not work that way. If that is leading to lower stall velocities, if that's leading to better stability of the aircraft, better mission parameters, then why not? Definitely go for it. Now, another thing that a lot of people struggle with is configuration selection. Now, what configuration should we go with? In historical design, there are plenty of configuration. So it has been found that there is no optimum configuration. It completely depends on the mission statement, how you are going to satisfy it. Okay. I mean, just to give you an example, you can have a very heavy motor driving a very small aircraft. So that's a thrust dependent aircraft, right? So there are a lot of different configurations. You have a canard, you have delta wings, etc., etc. So it would really help you to understand why we use delta wings in fighter aircrafts or supersonic aircrafts in general. Okay, or why do people go for something called as blended wing bodies that can be seen in the bottom left? Okay, that would help you to come up with some insights that what are the issues per se. That will help you gain insight into the aerodynamics of how things work. Okay, then you will be able to make a more cleaner or better judgment. Our suggestion here is when you are starting with the design phase, you can do a good pros and cons analysis of certain configurations that you really like and you feel are good. Once you have shortlisted 3-4 configurations, you can do an in-depth analysis of those 4 configurations and then take it forward. Professor, I think you have raised your hand. Please go ahead.
Yeah. Yeah. For example, among the 6 configurations shown in the right-hand side, definitely we can see that the bottom 2 on the right-hand side and the first on the left-hand side on the top is not suitable for this application. Okay. Yeah, because they are good configurations for other applications, but not for a supersonic UAV. I would go for either delta wing or swept back wing, or I may go for tapered wing. No, not even that. I would go for delta wing or swept back wing, or a blended wing body based on the requirement. Just a few words.
All right.
Yeah.
All right, so that is based on configuration. Like we said, there's no right configuration. It is all about how you are going to, address the problem statement that way. And while you analyze the problem statement, you understand that there are few configurations that work very well. Okay. So that is something that you need to figure out for yourself. And you have to look at literature, trends, and you need to check performance. Okay. So in the midterm report, we do not expect you to say that, okay, we have, gone ahead with a tapered wing configuration and we have frozen it. Done. No, it's a year-long competition. You can say that, okay, we have identified 3 or 4 promising configurations, configuration 1, 2, 3, and 4. Now, out of these four configurations, we would like to, spend some more time and, spend more time in evaluating all these 4 configurations. Based on that, when we do a detailed analysis, CFD, whatever analysis that you're doing, then you'll have a more better insight as to how things work. Then you'll say, okay, no, this probably does not work very well for us. Hence, we have chosen to discard this configuration and go ahead with configuration 3 and 1. That's perfectly fine. Okay. Moving ahead.
Okay, so one more thing I want to add is that although we are saying that we don't expect you to freeze the configuration, but if you have done enough studies and if you are convinced that one particular configuration is the final one, you can also decide and say that we have done it. I mean, don't try to unnecessarily have many configurations by mid-March. Okay, because that will also decide. So it's a team's call. We are not insisting that you freeze the configuration, but we are also not saying that you should not have a fixed configuration by this time. It's up to you. But explore and explain in your report.
Right. So whenever we are designing a supersonic vehicle, I mean, these are some parameters that, we could think of that we feel is something that you should definitely pay a good attention to. Wing sweep angle, airfoil shape, T by C ratio, Mach number, L by D, wave drag, control surfaces, etc., etc. And I'm sure I don't need to explain to you why these parameters are important, right? But as you are designers, we would really like you to pay good attention to these parameters while you are designing the aircraft. Okay. We'll quickly move over now. Again, some key aerodynamic parameters that really would change and shape your sonic vehicle or your Mach number, your coefficient of lift, your area distribution, your drag divergence Mach numbers, and you have your CPM, CRM, CYM, etc. And your propulsion system also plays a huge part here. Intake and duct consumability. Now, when we're talking about performance, what do we mean? What is performance? Performance simply, how is your aircraft, actually behaving? Could be in the form of, you can show BN diagram, you can show the angle of attack requirement, the versus Mach number things, you can show flight envelope, you can show the rate of climb, you can show altitude, you could show the structural limits, etc., etc. You could show a lot of things of what your aircraft is capable of. The more you show, the better you will feel that you have more insight as to what your aircraft is capable of doing. Right? So please give performance also a very good look, because that is something that we take a bit seriously. Now, this is something that I would like to mention here: importance of computational fluid dynamics. Okay, this becomes relatively important when we are talking about subsonic vehicles, right? Because when we are talking at low Reynolds numbers, subsonic and transonic, the effect is not very prominent. But when we are talking about high Reynolds number, and we are talking about greater than Mach 1, Mach 2, then CFD plays a very important, especially the low fidelity models, because modeling anything, and if you want to see the interaction of that of air with that particular airfoil or the wing surface, you're traveling at such high speeds, that is where CFD plays a crucial role. You can have a very, like you see, there's a compressibility correction factor that you need to account for, that can be seen in the left graph, and you can see what is the change in the drag once you hit the drag divergence. So all of that is really important. Just empirical methods probably might not do the trick when you are working on supersonic vehicles. So we recommend using of some CFD tools, but if you feel your empirical methods are good enough, then you could skip it as well. Okay, that's a call that your team would take. but CFD is also something that your team could look at, right? Now, some important points to remember. Please do not go out of the mission requirements. Please stay within the mission requirements. Over designing often leads to complication in the life of the designer. So we don't want to do that. Do a very thorough survey of the picture. Check all the parameters. Do a very good validation study. Match the numbers if they make sense to you, and what are the objectives that we want. Okay, calculate for all the phases of flight. It would have a subsonic flight, would have transonic and supersonic. Okay, calculate parameters for all the three phases. It will help you understanding your vehicle and its dynamics much better. All the parameters that you are quoting in your report or in the Viva when we meet, please make sure that they are justifiable and they make sense. Okay? Either you have taken it from the literature, either you have calculated it, or you have gotten it from CFD or your ANSYS or your whatever it is, CAD models. Please justify it, okay, and have a solid backing for it. Don't just say that, oh, we thought this might be used. That does not cut it. Have a good justification for the same, because one thing can lead to other problems as well. Yes, sir. Go ahead, please.
So here I want to also clarify that you may use some value, you may calculate some value based on some CFD tool or some FEM tool, but it should not make absolute nonsense just because you have calculated. You have to also ensure that it is in the correct ballpark, it is in the correct range, right? So we have had situations where people say CL max is 3.5, and for a small aircraft with no flaps, or CL max is equal to 10. Now you may get that number from some analysis, but that doesn't mean anything. Analysis is as good as the justifiable justifiable number. So don't go for paralysis by analysis, saying that we will analyze everything and get a number, and then but we cannot defend it. You have to defend your number with reasonable justification from published or from data related to supersonic aircraft. Okay, that's all.
Right. So moving ahead, before we go ahead, any questions? Because there is a simple case study that we would like to discuss. We would like to quickly take you over a simple case study that was done as a part of an NPTEL course taken by Professor Pal. And that
But
could be,
Pranav, I have a small point here. Sorry to interrupt you.
yes,
This case study is already available in the video form on the NPTEL course, which is freely available to everybody.
I'm not going to discuss it, sir. I'm just going to quickly go over it.
So we need not really spend too much time. In
Yes.
fact, why not use this time to maybe take some questions from the audience?
Yes,
So I would suggest, Pranav, I think I would suggest we take a break here and do this later.
Sure.
I would suggest that we open the floor for any questions.
Sure.
And
so,
for any doubts that may have.
So we have a couple of hands raised. Let's start with Team Agnivesh. Please unmute yourself, your video cam if possible, and ask a question.
Hi, sir.
Yes, please go ahead.
I'm audible, sir. Yeah.
Loud and clear.
How much of the weight have to be dropped? I mean, the 1000 kg payload, right? And how much of it should be dropped?
So when you design the aircraft with armament, you also design for a situation that the weight is taken but not dropped. Okay, so don't assume. Don't assume.
Ammunition.
No, it's not necessary that in every mission the aircraft will fire off all the ammunition. During trial flights, you will carry the weight and come back with the full weight. So you can assume that the aircraft has to carry that, but nothing will be dropped. Don't design it that every time it has to be dropped.
Yeah, that is okay, sir. I mean, all of the 1000 kg weight should be the droppable payload, or we need to have a guns and all.
Look,
like
you are being told very clearly, do not go beyond the mission profile. Why are you bringing in new things? You are not the customer. You are a designer. Correct? So the customer will tell
Okay,
you.
sir.
If we want to tell you something, we will tell you. So as far as you are concerned, you have to design for 1000 kg payload. That means whatever is the structure of the aircraft, apart from that, we will give you 1000 kg. It should be able to carry it. And assume that it has to be carried throughout. It may not be droppable. It may
Okay.
not be dropped.
And the
Because,
next question is,
yeah,
regarding the propulsion. It should be from the off the shelf, or can we use rubber engines?
that's a very good question. That's a very good question. My feeling is that either you use, see, we have to give you a proposed entry into service of this aircraft. I think that, Pranav, we have not given.
Right.
In the problem statement, we have not given the proposed entry. So we will give you that number, and what you have to do is either you have to say that this engine which we are using is likely to be available by that year, or you will say that current engine is progressing at this particular rate, the current engine technology, and it will reach that level in the year of entry. So either it will be based on an actual engine which is expected to reach that stage, or it will be a projection, so a reasonable projection. So we will give you the date of entry.
Okay,
We will upload that on the website.
okay, sir.
Okay.
And the third question is,
Right.
should the aircraft has to have the super cruise?
Is it mentioned in the problem statement?
No, that's why, sir. I mean, it is
Then
supersonic,
if it is
right?
not mentioned, it is not required.
Okay, sir.
If it is
Got it.
not mentioned, it is not required. Do not make your life hell by increasing your constraints. Don't bring your own constraints.
Yes, sir. Got it. Thank you, sir.
Right.
Some other
Next,
team?
Skybreakers, go ahead.
Hello, sir. My
Yes.
question is regarding your Pranav here, that you told that you should stick with a mission profile. At the same time, you told that you can do the code modification. Like there is a cruise altitude that is 14 kilometers.
Right.
You can see. So it is the minimum cruise altitude, or we can go above it also.
No, it is the desired cruise altitude. You cannot change it. The customer has told you that I want to fly at 14 kilometers. So
Sure,
you
sir.
have no business to change.
Okay, sir. Got it.
If the customer has said minimum 14, you should go for minimum 14. Then you can go to any altitude, but minimum 14. If the customer says 14, that means it is 14. See, what you are doing right now is called as requirements capture, which is a perfectly legal thing. This is exactly what we do with the customer. We try to understand the requirements. So the answer is it has to be exactly 14 kilometers. Not above, not below.
Okay, sir. Got it.
Right. Team Safira.
Yeah, so am I audible?
Yes.
Yeah, so my questions was from the mission profile, and so we wanted to know about the definition of range in this problem statement. Is it like a radius of action, or is it like you, let's say you
I
go
think I
drop
have
the bomb
answered
at,
this question. I've answered this question in the WhatsApp group. Can you go there and have a look? I've already answered this question in the WhatsApp group. We
like
have a
a similar
WhatsApp group.
question?
Yeah,
Yes.
next question.
So a similar question is there for endurance also. Is it the loitering time or is it the overall flight time?
Endurance basically means endurance at a particular station. It doesn't mean the whole flight time. See, endurance basically means I want to go to a place and then I want to do something for so many minutes or hours. How I reach there is not important. Once I reach there, I want to do half an hour, 20 minutes, 1 hour surveillance. So endurance is always on station.
Oh, okay. And as it was mentioned in the meeting that this is supposed to be a combat aircraft, but we have defined only one strike mission. So will it engage in air-to-air combat? So we have to. I'm asking it from not from the payload decision, but from the G's, SDR, and those kind of consideration.
Again, I would say if the mission profile does not show any combat or any G's, don't assume.
Okay. And like while so like will it be better if we reach the strike position as fast as possible?
You have been given a performance parameter to maximize. Am I right, Pranav?
Correct. There's a flight score associated.
That's it. Just aim for getting the better value of that in whatever way you think is better.
No, because that might involve a super cruise part also.
As I told you,
For the
super cruise
initial
has
test.
not been specified. If you want to provide super cruise, good luck to you. Please provide it. But in the process, if the aircraft becomes double heavy, we are not responsible. You lose the competition. You will provide super cruise, but I don't want it. I am the customer. I will not ask for something that you are providing. If you provide it to me, and if it is still better than other people, I might go for it. But I did not ask for it. You are giving me something I did not ask for. Generally, in design, it will come at a penalty. But if you are a brilliant designer, you might be able to provide all these features and still be the best, no problem.
Okay. That's all from my side. Thank you, sir.
Maverick, Team Maverick.
Hello, sir.
Yeah.
Sir, my question is from the mission profile. So, in the M1, I guess, in the M1 rule book, so it has mentioned that we should finalize the mission profile. But should we stick to the mission profile that we have given, or can we modify it according to our need?
I think I am repeating for the 5th time and the last time that mission profile is not your job. Mission profile is a job given to you by the user.
So, but in
So
the
when we
M1,
say finalize, so listen to me. When we say finalize mission profile, we want you to interpret our requirements and we want you to match it with the profile given.
okay.
That's it.
Okay.
But you are not supposed to change the mission profile.
Okay, sir. Thank you.
Team MacWorks.
I just had a very small question. What exactly is the duration of the loiter? Because from the references
I also have a question. Where is your camera?
I really apologize for that. I'm in a really low network area right now. I would love to turn it on.
No problem. That's okay. That's fine. Yeah, sorry. What is your question?
My question was, what exactly is the loiter duration? I have read up some references. I can see a range from 45 minutes to 7 hours. Could you please elaborate on it?
No. If a 45-minute endurance is given in a transport aircraft or alternative airport, it's nothing to do with the military aircraft. So, Pranav, have we not given the loiter duration in the problem statement?
In the problem statement, there is a parameter, competitive performance parameter that we are looking for, in which teams are required to maximize endurance, range, basically the aerodynamic efficiency, right? So we have given basic endurance that we are looking at, basic range that we are looking at, minimum and minimum takeoff distance. So anything more than that is up to them to optimize.
No, have we given the endurance value?
Yes, we have given minimum endurance
how
of
much?
2 hours. We have given in the problem statement.
Other than why is he asking what is the endurance? The endurance is 2 hours.
Sir, I asked the loiter duration. I understand the endurance duration.
Is there a loiter there, Pranav?
There is a loiter, but this is the entire endurance part of it.
No. So clarify. So when we say endurance, we actually mean endurance during that loiter.
Understood, sir.
All right.
Okay. Team Mark 4, Mark 5.
Uh, so I have a couple of questions, sir. So is there like a minimum screening height that you guys that we have to consider while designing the aircraft?
The screening height for combat aircraft is already specified. There's no need for us to specify. It is 50 feet. 50
Okay,
feet for
so we
takeoff,
just
50 feet for landing. Yeah, it's given. When you study about combat aircraft design, you will realize that for a civil aircraft, there are two screen heights, one for takeoff, one for landing. But for military aircraft, the screen height is 50 feet for takeoff and 50 feet for landing. That is the specification.
okay, sir. Understood.
Good question.
And
Good question. Good question. Yeah. Next.
is there any specific payload to be considered, like particular shape or design that we have to take into account while, I mean, I know that only mass matters the most, but then should we take like the size or shape into account as well?
None of your business right now. See, if you are smart, you would say that this 1,000 kg payload is going to be carried inside the aircraft so that it doesn't create drag. Okay. But if you want to suspend it below, then you need from us the geometrical data. So we will give you the geometrical data of the payload. Pranav, make a
So
note.
yeah,
We will give them the geometrical data.
We have already finalized it. We have not released it yet. We'll release it, the payload per se.
See, at this stage, honestly, I don't think you need to go into the nitty-gritty of the payload. When you come to the last stage, then definitely. But we have no problem in giving you data. We did not want to confuse you and we will lead to wastage of time. But we will give you that. Right now, you worry about
okay,
1,000
sir.
kg.
Got it. And then my last question would be, what should like there's a scoring parameter given in the rule book. So is there a good range for the particular scoring parameter?
No, it should be better than the best. So
But then
see, if you tell, yeah, it is up to you. See, ultimately, we are going to calculate that parameter for all the teams, and we will declare that this particular team meets all the requirements. They have followed the mission profile faithfully, and their score is the highest. So see, we want to leave a room for innovation here. How you minimize it? Do you maximize the numerator? Do you minimize the denominator? Do you do both? So we don't want to give you a number. We
what
don't
we
know
thought was
ourselves.
you.
No.
Sorry, sir.
We don't have any number ourselves right now.
Okay.
We are just saying higher the better. That's it.
What we thought while designing was if we have a reference scoring parameter, so we'll consider all the parameters based on that as well. So that was a design
No,
approach.
no.
One
You
of the
try
ways
to.
of
You choose your parameters. You choose your this one based on the requirement to maximize that number. That's it.
okay, sir. Got it. Thank you.
Team Shiv's Trident. Yes.
Good evening, sir.
Yeah.
Sir, my question is regarding the mission profile approach for strike mission. It should just drop the payloads like bomber, or it should perform the high G maneuvers and then.
I have already answered this question few minutes ago. I will again answer it. If there is no mention of high G maneuver, don't assume anything. Assume that the payload is simply dropped.
Okay. Okay.
Don't try to do more than what is required.
Okay.
Any other team has any question? I'm very happy. I'm very happy at the way questions are being asked because it shows that you are trying to immerse yourself in the problem. That is exactly what we wanted. in this particular stage. You should be breathing and thinking and sleeping over this problem statement. It should come in your dreams. And therefore, we are happy to clarify all your doubts. Sudarshana, Team Sudarshana. Go ahead.
Good evening, sir. Sir, actually, few minutes back you told that endurance we are talking about at the target. So 2 hours of endurance at the target, right? But
Not at a target. No, 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 no. Is there a loiter phase given in the problem statement?
yes, a loiter at the end of the mission it is given.
Whatever. So wherever it is, we want 2 hours in that phase.
Okay. Thank you, sir.
I don't think we have any more questions for now. I just have last 2 slides to show, 2 or 3 slides with regards to the propulsion part, and then probably we can ask you can ask some more questions, and then we can wrap up. Team Garuda, just give me 5 minutes. I want to cover this up because it's already 9 o'clock. We also have to wrap this up. So just give me 5 minutes. Let me present 2 or 3 slides, and then you can go ahead with your questions. Okay, fair. Right. So I am not going to discuss in detail about this F-16 case study, but this is a case study that was done as a part of the NPTEL course by Professor Pant. This gives us a lot of insight. So we would request you to go and have a look at that. I have the slides with me, but I am not going to discuss it. It is a tutorial on refined sizing of jet fighter aircraft, right? So you can see the example of our F-16 aircraft and how it has been theoretically modeled. Of course, what you are going to do is going to be a bit more than that, but this could be a great starting point for you, right? Again, so this is just want to show how the slides look like when you actually see it. So this is what it is. Just hide the floating controls. Okay. So this is the mission requirement that was given for that vehicle. Then how it was taken forward, the weight estimation, etc., etc. What methodology was followed, how it was analyzed, takeoff weight, etc., converged values, symbols, the difference in sizing, parameters, etc., empty weight fractions, and this would give you a fair enough idea. Now, what I would like to talk to you about is another important thing, which is propulsion system and energy balance. So as you know, whatever energy, whatever fuel you're carrying should be enough for you to perform the task given to you. So that is why energy balance and propulsion system are really important part of any design. Okay. So the propulsion system, the key design considerations would be a high efficiency air intake, variable air combustor. You have to look at nozzle designs. You have to look at engine cycle analysis, weight estimation, and thrust analysis. Some parameters that you could look at. Okay. Any engine that you are looking, you have to make sure that it is satisfying your criteria as well as bringing in some kind of novel aspect to it. Okay. How is it, the best fit for your design? It should not be that, okay, we found this design and we have used it. So it should be really, tailored for your design. That, okay, this is why it makes a lot of sense for your design. Okay. Now, assessing energy balance, right? Now, key factors which would really offset your energy balance or would give you a lot of insight into energy balance would be your drag. That is not just the wave drag, the entire drag, parasite drag, as well as other forms of drag, your engine efficiency, your altitude, and your capacity. Okay. Now, the ways in which you could probably, better your energy balance. Advanced aerodynamics, you always have to strive towards improving the aerodynamic efficiency, but not at the cost of structural efficiency and other subsystems taking a hit. Okay. You can use a good propulsion technology, advanced material, sustainable aviation fuel. This is a very generic thing to say, but what is challenging is to look at the interplay between all of them. Okay, that is which is going to be a challenging aspect for you, and we would like to see that. Okay, one small tip that I would like to give, we would also like to see some innovative things come into picture. Okay, year on year, we have seen NACDeC, since it being a year-long problem statement, many people work on it and come up with a lot of novel solutions, and they work on it a bit more, refine their designs, and they are able to publish it. They're able to publish their work in a conference, journal, etc. So give good attention to the problem statement. so that you can also strive to have your work published. Okay, that would be a very good culmination to this project that you have done. So yeah, that's it from my end. I think you have any questions, we would definitely address that. Before I take on any questions, just one simple thing I always mention, that guys, approach this problem as any engineer would. Okay. Don't think of it as your assignment, classroom assignment, or anything that you do in your college or something. Think of it as actual engineering activity. If you step out in the industry, or you join government organizations, so this is what you are required to do. I think this is something where I can throw in my 2 cents. Where when you are working with organizations like ISRO, DRDO, they expect you to give a very precise number and precise justification. Okay, so I wish you well for that, and I'll give my closing remarks once I take questions as well. So I think Pansa, you have something to add on. Please go ahead, and we'll take questions.
So Pranav, you have raised a very interesting point about publishing of papers based on the work done by NACDeC. I'm happy to share that some teams in the past have managed to do it successfully, and some teams are also doing it. Only one request I want to make is that whenever you write any paper based on NACDeC or any report based on NACDeC work, we will be delighted if you can acknowledge, if you can just mention in the acknowledgements that this particular work was done to address the problem statement of NACDeC, because that will get us also more visibility, and also it will add a lot of credibility to your work, because NACDeC is now a very well known and very well respected competition. After this is the 8th year, as you know. So over the years, it has built a lot of credibility. So even your journal or your conference paper acceptance chances will be better, and I mean it will be liked by the reviewers if they come to know that this is a part of your NACDeC work. And for us, it's a very satisfying feeling that students have utilized their NACDeC problem work into a paper. Okay? I am not saying that you have to put us as authors or anything. No, we are not interested in that. We are only interested in getting the due credit to NACDeC. Okay. That's all, Pranav. I'm through.
Yeah.
The floor is now open for any questions anybody has.
Questions. Team Garuda, go ahead. You have your hand raised for a long time. You can ask your question.
So, do we also have to design the internal structure for the aircraft?
Yes, the answer is yes, but that will come in the next stage. It will not be required in the midterm report. That comes at a later stage, because when you estimate the weight of the aircraft, you will initially use some empirical numbers or some basic assumptions. But later on, definitely it will be expected that you do some stress calculations and structural sizing calculations to justify the number that you have got. But we are not asking for detailed design. That is difficult and almost impossible to do at this level. But some amount of structural weight estimation, higher than just saying that we got it from literature, will be needed. It will add value to your work.
Thank you, sir.
Team Stealth.
Okay. Am I audible?
Yeah, you're audible. Go ahead.
Okay. So my question is on the problem statement. On the sample mission profile that you sent us.
Right.
If you check those two cruise segments, they are almost identical. So does this mean that this USCAV should always return back to the base?
Yes, that is the thing. We expect it to go do something and come back.
Okay. Thank you.
Safira.
Yeah, so my question is on the future webinars. So, like, we would like to have it's like a request. Like, we would like to have a webinar on the different kinds of ETs, like reliability, feasibility. So, is it possible?
So regarding
it is possible. It is No, it is possible, but it is not relevant right now. We will do it because you are entitled as a student to know about the ETs. But you will notice that we have not demanded any ETs in the problem statement because in a conceptual level, it will be difficult for you. However, you definitely should provide features which will make it more reliable, more lower susceptibility, and better maintainability. So definitely we will arrange a webinar, but not immediately. We will do it after the midterm report. Pranav, please go ahead.
Yeah, one more point that I would just like to add with regards to the webinar. This is to all the teams. So, guys, it would be really helpful for us. Whatever things you are, facing difficulty in can be, in a due course of time, and you feel that this is something you need more clarity on. Feel free to type in the WhatsApp group that this is something that we would really want a webinar to be on. Okay, it might be that we might conduct it, we might not. But if you have a consensus, then we might make it a point to call an expert in that domain to help you with that. If it is a relevant topic, if it covers the basis, then we would definitely make it a point to call an expert person to handle those queries that you are facing. So please use the WhatsApp group well, and please give us a good heads up, because we need to get in touch with that expert, work with him, and address your queries. So it takes some time for us as well. So please be proactive, and we want you guys to take an initiative and say that please have a webinar. We would be more than happy. If you are motivated, that gives us a lot of joy and pleasure. So you have to drive. Okay, otherwise it feels like that we can suggest topics, but how much sense does it make to you is something that we don't have a lot of clarity. Okay, so please, you have to be in the driver's seat. Raise your voices in the chat, in the WhatsApp group, and say we would love to have, let's say, stability, or something more on propulsion system design. It could be anything what you are facing problems at, or something you need more insights at. We would make sure if we can handle it, we would do it for you guys. If not, we would make it a point to call some industry expert or academia expert who can shed some light on that. That's it. Okay.
So in this context, I'm very thankful to Team Safira for suggesting a wonderful topic about the LEDs. So thank you, Team Safira. We are going to get an expert to talk at the appropriate time.
Right.
Abhimanyu 8.0, please go ahead with your question.
Hello, sir. I had a very small question. So from the problem statement, it is understood that the takeoff and climb will happen at subsonic and the cruise will be at supersonic. But we just wanted some clarification on whether to consider the strike to be happening at supersonic speed or the subsonic speed.
I think you have been specified what is the Mach number in each segment. Am I right, Pranav?
No, they have not been specified that, because of that leads to them deciding the aerodynamics of the aircraft. That is something that they have to do themselves. So again, to answer this question, we would want it to be primarily the strike part. Okay, would probably be a supersonic strike. That is what we would like to go for. But there is a caveat here that I would like to say. When you look at the flight formula, flight score that we have given, okay, if you are able to just be above Mach 1 for the strike and able to maximize it, then also it works.
Okay, sir. That answered the question. Thank you.
Okay,
yeah,
cool.
but I think Pranav, one of the selling point of this UAV is quick response to a threat. So it will be nice if they can travel very fast to the point where they want to engage in combat.
Hence, sir, the Mach number comes into the formula, right? So that is where it comes into the formula. So that they have to try to maximize it to some extent. So there you have it. It's an interplay of these parameters: range, endurance, Mach number. You have to play with those parameters. Anything else, Abhimanyu?
No, thank you. That's all. Thank you.
Cool. Pand UAV, go ahead.
Yeah, hello, sir.
Yeah, go ahead.
Am I audible? Hello.
Yes, you are.
Yeah. Sir, my question is that, like in midterm report, how much is expected from us regarding the stability of the aircraft? As you mentioned earlier, that the stability of the aircraft changes when it enters the Mach value, and we won't be freezing the some. one single configuration for the midterm report. So it would be very difficult for us to do the stability for different configurations. So how much is expected from us regarding the midterm report?
Right. So with regards to your stability analysis, that's a very fair question. So when, let's say, team Point UAV, you have shortlisted, let's say, 5 configurations, okay,
Yeah.
and that you feel you would like to analyze further. I would not expect you to do a very deep dynamic stability analysis for all 5, because that would be really time consuming. But I want you to do a basic stability check and see which configuration you feel has the potential to be taken forward. If you feel that a configuration is not stable at all, okay, then you can disregard it. Okay, giving stability reasons. You can show that you have done some basic stability calculation, basic static stability, you have the directional stability calculations, etc. You can show basic study, not in depth. Okay. As to your selection, as to your criteria for selecting or rejecting a configuration. Okay. Once you say that we have narrowed it down to 1 configuration or 2 configuration, there we would like to see some detailed stability aspects coming into play. That is when you reach the final stages. Okay. If you do reach the final stages, there we would like to see the dynamics, the stability, how it works in various segments of life. It can be your subsonic, transonic, and supersonic. How does the stability change, and what parameters are influencing it? That is something I would say is more for the final stage. For now,
Okay.
keep it a bit cursory, but it should not be that you have chosen an unstable configuration and you have gone ahead. Make sure
Yeah.
that the stability checkbox is also made is there, and then when you're doing your final calculation, just do a deep dive.
Thank you, sir.
Cool. Safira, do you have any more questions, or you have not put down your hand?
Yeah, actually, I have one more question, and I cannot switch on my camera because of low bandwidth.
Go ahead.
Yeah, so actually, I had one more question regarding the strike. So, can you throw more light on the strike? Like, what kind of strike will it be? Is it be a dive kind of a thing, or carpet bomb, or something like that?
Okay. So, with regards to this question, when we were formulating the problem statement, what we could probably do is we will give you a strike radius. All right. I think that would help you. Okay. So there would be a radius where you need to drop those particular ancillaries. Okay. And you need to make sure that it drops in that particular drop zone radius. Okay. That is something that we could provide you. But it is, I think, pretty standard boilerplate that you need to keep that radius as low as possible. Okay. But we can provide it to you as well. So go with the assumption that there is a radius in which you need to drop your ancillaries, and the vehicle has to quickly navigate and come. Does that make sense?
So, this radius, is it like combat radius, or is it from the point where you are starting the strike?
Combat radius.
Okay.
That drop
No,
radius.
but actually, I wanted to know about
Okay. I'll tell you. Assume right now that the payload is dropped in level flight. No turning, no maneuver, no G, no dive.
Okay. Okay.
Team Trishul.
Yes, sir. So I was going through your NPTEL video series and I came across cost. Cost is the driving factor. So, I also asked on the group that in case of commercial aircrafts, cost is a major thing. But when it comes to military aircrafts, usually states are willing to spend a lot of money. Still, the fuel and maintenance is a relevant factor. But
What did I answer? What did I answer there?
yeah, so it's not mentioned anywhere, but while selecting material and other things, we might have to consider it.
No, what did I answer in the WhatsApp group regarding your
You
question?
answered that just follow whatever is mentioned in the problem statement.
Exactly. There is no mention in the problem statement of operating cost or reducing operating cost or initial cost. Correct?
Yes.
Don't worry about it. See, you are all, because my NPTEL video has so many things, that doesn't mean everything has to be done. You have to take from there what is useful for you for the current problem statement.
Also, Team Trishul, if you look at the problem statement, the cost part is something which is given in the problem statement as something not to be done. Okay. Because if you look at aircraft design, it has 3 phases. You are just doing phase 1 of it. That's conceptual design. Okay. There are other things also. And just one small correction, please don't be under this wrong impression that states are willing to spend a lot of money if it's a defense aircraft. It is not the case. Okay. They are hard taskmasters. Okay. It does not mean that it's commercial. So we will, go for budget aircrafts. And when it's, a supersonic aircraft or a military aircraft, we can splurge. But that's not the case. All right.
One more question. In the earlier webinar, it was mentioned that Mach number has to be something like minimum Mach number or something 1.8. So does it still hold, or we have to like reach that number by ourselves,
I
like
don't
any
think
number?
that minimum 1.8 mark has been mentioned. I do not recall that. So Mach number is something that you need to figure out for yourself because it is a parameter that you need to optimize. It is in the flight score, right? So we are not going to provide that. But that being said, it's a supersonic aircraft, so you need to design it appropriately.
So shall we say that the Mach number has to be more than 1? That's all?
Yeah, I mean that's obvious. It's a supersonic vehicle. Done.
Yeah,
So
but let us clarify. So we are only saying right now that we are not saying that the Mach number should be so much or should not be so much. We are just saying it should be supersonic.
Okay. So I think that brings us to the end of this webinar. We have spent a good 90-95 minutes on answering queries. I hope this session was informative to some extent and give some clarity. Team Sudarshana, go ahead if you have any questions. If not, then
Like just now you said it should be supersonic, but it relies only in the part of the strike reason. So we can cruise with subsonic and then do a supersonic segment, or it again you mean a entire supersonic cruise? Not.
so for that, we would recommend that for your subsonic, there will be a takeoff aspect which will be subsonic. In the strike part, it definitely has to be supersonic. That is the entire objective. And see, if the point is that if you are trying to maximize your range, it has to go at a faster speed, right? So that would necessitate you to use supersonic. If you say that you're going to use subsonic, that defeats the purpose of the vehicle. If your objective is it takes about 2 hours to reach that place and then you are bombing it, then that kind of defeats the purpose. So avoid going for subsonic cruise. It could be a
So all teams, please look at the performance parameter very carefully and then decide. You don't just ask questions without keeping in mind the performance parameter. So Pranav has already answered. If you go subsonic, you are going to have lower performance parameter. So it may be very efficient, but it will not win.
Right. Okay.
And you cannot make it fly at very high supersonic Mach number also just to be greedy. But then the whole aircraft will become very heavy, lot of fuel. So you have to do analysis, you have to do trials and then come up with the number. That's why we have given a objective function.
Okay, sir.
We are giving you the flexibility to choose.
Okay, thank you, sir.
Right. All right. I think we have safely answered almost all questions. So some quick concluding remarks from my end. So your midterm report is due on 15th of March. We will definitely try to have one webinar before that, to address some more queries that you have at that time. One more tip from my end, please use, again, as I said, please use our WhatsApp group very well so that you can, suggest topics for us. And, we would love to hear feedback also. How was the webinar? How do you feel is a progression? If there anything that you're not really happy with, you can voice your opinion, but send us private mails as well. We are looking into that. And the last thing I would say that guys, just have fun with the process. Okay? If you're not having fun, there's no point. It can be a great learning experience, also a great teamwork and bonding experience. So my best wishes to all of you, and have fun. Sir, over to you.
Pranav, can we roughly fix the date of the next webinar? I mean, I would suggest 26th of February, because that would be 1-2 weeks before the deadline.
Yeah, I think somewhere around that would work for me. I think I would go for 28th, the last day, because it would give us 3
No,
weeks.
but yeah, what you say is right. My problem is I will be traveling on 27th. 28th, I plan to be in IIT Bombay. Okay, so we can keep on 28th.
So we can do a poll also at that time and we'll see.
Fine, we can do a poll and we can ask for the teams to tell us.
Sure. So, sir, any other closing remarks from your end? Otherwise, I'll
No,
stop.
nothing. I'm very happy at the way in which this competition is going, because I see that students have lot of questions and they are very inquisitive about this. So that is great. It's great. So let's keep the tempo, guys, and use the WhatsApp group. Only thing I am requesting again and again is do not send a direct message to me or to my team members on WhatsApp or on email. Don't pick up the phone and start calling us or sending us WhatsApp messages. Please use only the WhatsApp group, only and only the WhatsApp group, and be patient. You may ask a question and we may not be able to answer immediately. We may be busy with something. Okay, so do not call us, do not send us direct message. We all have other things to do, like you have so many things to do. This is one of the things we are doing. Okay, we are also volunteers. So we don't like if you call in the middle of the night. It has happened in the past. I have some doubts, sir, and they will call you in the middle of a class or in the middle of an activity. That's not acceptable. WhatsApp group is there. There are volunteers. Whoever is able to answer will answer. There is also an email. I agree that email is not being watched regularly. Maybe we will do something about it. But WhatsApp group, I can promise you, is immediately everybody is able to watch it. Okay, with that, I would like to leave. It's quite a good webinar we had. Okay. And sorry for the initial problem that we faced. At least this webinar has gone for a much longer time because we switched to my personal account. Okay, so I'll be leaving the meeting now.
All right. Thank you so much, everyone, for attending, and have a good evening. I am ending the live stream as well as the meeting. Thank you. Bye-bye.
Thank you, sir.